Hello, my name is Marita Salazar and I work for the Office of Student Success as a tutor for Digital Fundamentals. Today I will be demonstrating how to work on Demorgan's theorem. First of all, we're going to look at the logic gates. Here we have our AND gate, the Boolean equation, which would be this one here, is A and B. At the OR gate, we have our Boolean equation being A or B. Our inverter has not A. Our NAND gate is the same as an AND gate. It's similar to this one, but it has an inverted output. So our Boolean equation would be read as A and B not. Looking at our NOR gate is very similar to our OR gate, and we'll be seeing A or B not. Next, we have the laws of Boolean algebra. We start off with our commutative law, which is A or B is equal to B or A. The way we would draw in a schematic form would be this way. We would have our OR gate, so it would be read as A or B. If we put our inputs as B or A, this is our Boolean equation. Same thing goes for an AND gate. We have A and B equal to B and A. Our next law is the associative laws. In this one, we have A or B or C. The way we would draw this would be with two OR gates, and then this is equal to our A or B or C. So we have both our A or B inputs going into an OR gate and coming out into another OR gate with the C. Next, we have our ANDs, A and B and C. So the way we would draw that in schematic form would be two AND gates with these inputs. And that is equal to A and B and C. Next, we have our distributive laws. In our distributive laws, we have A and B or C is the same as A and B or A and C. The way we would draw this one in schematic form would be with an OR gate with the inputs of B or C going to an AND gate with the inputs of A. The way we would draw this one in schematic form would be two AND gates with the inputs of A and B, and the other one with the inputs of A and C. And these both go into this would equal to AC. The output of this one would be equal to AB, and when going into the OR gate, they're equal to AB or AC. Next, we have the rules for Boolean algebra. Our rules for Boolean algebra are as follows. Number 1, A or 0 is equal to A. 2, A or 1 is equal to 1. Number 3, A and 0 is equal to 0. Number 4, A and 1 is equal to A. Rule 5 is A or A is equal to A, and A or not A is equal to 1. Rule 7 is A and A is equal to A. Number 8 is A and not A is equal to 0. Number 9, A not is equal to A. Number 10, A or AB is equal to A. Number 11, A or not AB is equal to A or B. And number 12 is A or B and A or C is equal to A or BC. And finally, we have Demorgan's theorem. The theorem 1 is A and B naught is equal to not A or not B. And in theorem 2, we have A or B naught is equal to not A and not B. For these rules, we have to remember to break the sign, break the bar, and change the operator. This concludes the laws for the following example.